Welcome to Summarize Science. What if an AI could take a standard, inexpensive medical slide and digitally repaint it to reveal specific signs of disease, like cancer markers? This technology is called virtual immunohistochemistry, and it promises to make diagnostics faster and cheaper. But the biggest hurdle is trust. How can we be sure the AI's generated image is medically accurate and not just a convincing fake? This paper introduces a new framework to automatically answer that question. Normally, pathologists use a general H&E stain, but sometimes they need a special IHC stain, which uses antibodies to turn specific cells brown, highlighting problem areas. The goal is to train an AI to create a virtual IHC image from a simple H&E image. The researchers' key idea was to move beyond judging if the image just looks good and instead measure if the AI colored the correct pixels brown. They tested 16 different AI models, each with a unique approach to this digital painting task. Here you can see examples of what these AI models produce compared to a real IHC slide. Notice how some models miss staining important cells, which are false negatives, while others incorrectly stain areas that should be clear, creating false positives. A major finding was that the traditional metrics used to judge AI images are not reliable for this task. For example, this graph shows that a standard metric called FID has almost no correlation with what a human pathologist would consider a high-quality, accurate image. This means an image could score highly on a technical level while being completely wrong from a medical standpoint. To solve this, the researchers developed a new system based on accuracy. They used an algorithm to create a mask of all the brown, stained pixels on the real slide and another mask for the AI's virtual slide. Then, they directly compared these masks to get a true accuracy score, essentially playing an automated game of spot the difference. As you can see here, this approach confirmed that the old metrics for image fidelity do not reflect true staining accuracy. The challenge gets even bigger when moving from small image patches to a massive whole slide image. Many models that performed well on patches started to show ugly tiling artifacts, like visible seams where the AI stitched its work together. This proves that for these tools to be clinically useful, they must be benchmarked on the full, complex scale of a real pathologist's workflow. So, let's recap the key points. First, when it comes to medical AI, accuracy is far more important than just creating a realistic-looking image. Second, the standard metrics we use for AI images are not good enough to measure this medical accuracy. And third, this paper provides a new, automated framework that can measure accuracy, which is a critical step for building trust in these powerful new tools. The ability to reliably and automatically check the work of these AIs is essential for their adoption in clinics. This framework helps separate the truly useful models from the ones that just create pretty pictures. Ultimately, building this trust could accelerate the use of virtual staining, making pathology more efficient, less expensive, and more accessible to patients everywhere. Thanks for watching Summarize Science.